Hi, Science 30s. Mr. Riley here. This is like my third or fourth video now. I feel like I'm getting pretty good at this. I don't know about you guys. We're going to look at some pH indicators and how to find the pH of a solution using indicators. So what we need to look at here first is on page 12 of your data booklet, you're going to see this table, and it shows all the common acid-base indicators, their pH range. This is what we want to pay attention to. The pH range, where color change is going to happen, and what the color change is. Okay, so those are the two things we're going to need. So, for example, if I look at, let's, for example, chlorophenol red is the one I got here. So its pH range is 5.2 to 6.8. So that means over that pH range, if I have chlorophenol red, I put that into my solution, over that range, there's going to be a color change. So what that basically tells us is that anything that is 5.2 or below this way is going to be, I have a highlighter here, it's going to be yellow, and anything that is 6.8 or greater is going to be red. So any solution of pH 5.2 or less is going to be yellow. If it's 6.8 or greater, the solution is going to be red. Now, if it's between 5.2 and 6.8, you got to think back to kindergarten color lessons. Yellow and red is going to make orange. So that's a piece we might need to have in here as well. So let's look at an example problem here. Here's example number one. Okay, so we have a solution, and we put a few different indicators in and got some different colors. So the first one's bromothiamyl blue, and the color is blue. So when I look up at bromothiamyl blue, I'm going to go find it here. Oh, here it is. Okay, 6 to 7.6, it goes yellow to blue. So that means if the solution is blue, it's going to be on this high end. So it's going to be 7.6 or greater. So I'm going to put 7.6 to 14. Phenolphthalein is colorless. So if I go find phenolphthalein, 8.2 to 10, it goes colorless to pink. So colorless is on the low side of this. So that means my pH has to be 0 to 8.2. And phenol red is red. So if I go find phenol red is right between those. It's red, and it goes yellow to red. So it's going to be on that high end. It's going to be 8.0 or greater. So 8.0 to 14. So I'm putting 14. That's the highest that our pH is going to go. So this is kind of a logic problem. I need to find a pH range where all three of these are true. And there's a couple different ways we can do that. I mean, the easiest way for me is all of these can be true for, if I look on the low side of these and pick the highest one, and I go on the high side of these and I pick the lowest one, and that's going to be 8.2. So that means for all of these things to be true, my pH has to be between 8.0 and 8.2, right? For all of those to be true, that's the only possibility, okay? And that's how we do those problems. Now I might say, or estimate the pH. I would find the average of these. So if I wanted one number, it would be 8.1. It would be the average of those, okay? So I want you guys to try one of these. So here is one for you guys to try. Pause the video or whatever and give this one a try and see what you get. Okay, so I'm going to go through the solution now. Some of you, I know you didn't pause it. I see you. You're non-pausers. You didn't do the problem. But let's do it together here. So litmus is red. So I'm going to go all the way back up to my chart here and find litmus. And so litmus goes red to blue, 4.5 to 8.3. So I'm on the low end of that. So that means I'm going to be 4.5 or less. So I'm going to put my pH range for litmus 0 to 4.5. And thymol blue is orange. So I'm going to go to thymol blue. Now, thymol blue is kind of a weird one. There's actually two of them on here. There's two ranges. So if I'm orange, I need to be between red and yellow. And so that means I'm going to be between 1.2, and 2.8. Wow, that's a really small range here. So 1.2 to 2.8. And orange 4 is red. So I got to go up here. I'm going to go find orange 4. Orange 4 is right here. And orange 4 is red. Means it's on the low end of this. So it's going to be 0 to 1.4. So let's go put that in here and see what we get. 0 to 1.4. Okay. So now I want to estimate the pH of the solution. So I'm going to take the high number on the low end of these. That's 1.2. And I'm just going to take the lowest number on the high end of these, and that's 1.4. So I know my pH has to be 1.2 to 1.4 for this solution. Now, if I want one number where it says estimate the pH of the solution, I want to find the average of these. So if I add them both together, I divide by 2, I'm going to get 1.3 for my pH. Okay. Now we can add something to this. Question B says estimate the hydronium ion concentration of the solution. So we got to think back and say, well, if I want to calculate my hydronium ion concentration, I'm going to take 10 to the negative pH. So I'm going to take 10 to the negative 1.3, and I'm going to put that in my calculator. So I'm going to take second function log 10 to the power of negative 1.3, close my bracket, and I get 0.050. Okay. Or I could say, let's say 5.0 times 10 to the negative 2 moles per liter. Okay, so we added a different layer to that problem. So this became a two-step problem for you guys. I'll have some more practice for you guys to do later. I hope you're enjoying these videos. I hope they're helping. I hope you guys are doing great. Talk to you later.